So today subject is IoT and applications. Class 5. Class 5? 4? 5? Right. So the logic condition of IoT, we have seen its functional block diagram. Don't get confused. There is a block diagram for IoT device also. Don't get confused. Right. So in the exam, generally what happens? One question is asked, they write answer for the other. Clear? There is a block diagram for IoT device. There is a functional block diagram. In functional block diagram, we can see functional components. Is this clear? Right. So, in the last class, we have discussed the functional block diagram. What are the functions of a IoT device? Taking example of a mobile phone. Today we will see the second component. Right. So, what are the logical? One is functional block diagram. Second one is the communication models of IoT by default it will come. Then we have communication, that is APIs, application programming interface. So today let us see communication models. Then after that, with the time permits, we will see communication APIs. In the last class, I have given you how many communication models are there. So let us start discussing one by one. First one is request response communication model. CM is what? Communication model. First one. Basically, what are these communication models? The communication models tell us how, or rather, I will say, it will describe how communication or interaction. Communication is exchange of information happens between two or more devices or systems. How they interact, how they communicate, it is how they exchange the data or information. It means they will also tell, right, who is right, who sends data, who receives, right, RECIEVs, receives data. Is this clear? The first one is request response communication model. Here in request response communication model, we have two characters. One is client, another one is server. We have two characters. One is client, another one is server. As the name itself indicates, one is sending the request, another one is sending the response. Here, the client always sends the request. The client always sends the request. Sure, is it recording?
Yes, sir.
The client has to initiate the communication. How it works? How it works? sends request, client sends the request. We can see its diagram in the form also, in the form of block diagram. But you know, I have a client here, I have a server, I have a resource here. Resource is what? The data. What? Client sends the request. Client sends the request. You can see the arrow. Then, once the server receives the request, it process. Once the server receive request, what does it do? It process. It do some processing. It fetches the data, whatever. It fetches the data, whatever client has requested. Client is seeking something, some information, some data. That data it fetches from the resource. Where it fetches the data from here, and the data will come back. Right, what does it do? It process, it fetches. And response to the client and respond to the client with the data. Right. Response to client with the requested data. The data that is being requested. As simple as this. This idea. So here what was the condition? The condition is client must initiate communication. Client must initiate communication. What are the key points? Simple, act reliable. It is simple. The system is simple. Client sends the request. Server responds to the data. Prepare and respond. Right. Simple and reliable. And another point I have done here. Another important point I have written here. Example. Suppose you want to see your result. Suppose you want to see your attendance percentage. What you do? You type www.rgkt.pc.in. It is a request response form. The data you see, the RGKT server will process it, will fetch the required data, and it will send back to you. It will send back to you. Right. So example is right. I have given you right. The browser. Click on it. Type www. What are the data you are seeking? It will give back. Right. Let us take IoT example. Right. An application request temperature. Which is collected, right? Which is collected by a device with sensor. Yeah. One is general example, another one is IoT example. So yesterday I have given, right? These are different types. So which is the second one? Publish, subscribe, communication model. Publish, subscribe. Right. So there is some meaning of name also. The name of communication model. Publish, subscribe. In day-to-day life it happens. You subscribe for a newspaper. Some will subscribe for the Hindu newspaper. Some subscribe for Indian Express newspaper. Some will subscribe for Sakshi. Whoever subscribe, or only the paper will be delivered. It works similarly here, but in the digital world. In the digital world. Some will subscribe for Netflix. Some will take subscription from Amazon Prime. Isn't it? Then only you will be able to access the content. Right. So, in publish subscribe model, how it works? How it works? Publisher send message to topic. I will explain the proper diagram. Right. I have consumer here, consumer 1, consumer 2, consumer 3. Here we have one more character called as broker. Here we have publisher. So how many characters are here? There are 3 characters. One is publisher, another one is broker, the third one is consumers, collectively consumers. Now here in the broker we have topic 1, topic 2. So different newspapers or even OTT platforms. Here subscriber, here consumer 1, consumer 2. That is this person, this person. Here also there are subscribers. Say consumer there. They will subscribe for topic. Right. Now what? Publisher send messages to the topic. Message or what I can present data or information. Right. The publisher send message to the topics. Right. So subscribers, the subscribers receive message from topic, not publishers. Remember. So publish, subscriber, they do not know each other. They do not know each other. Right. Say on Netflix, there is a triple R movie. The distributors has shared them. Right. It's a broker. Amazon, Netflix, these are all brokers. Triple R movie distributors are given a movie. You are subscribed. The Netflix person knows you, but the distributor of a movie does not know you. Is it clear? Some key points. Some key points. The key means important points. Scalable. Scalable means it can grow. New movies can be added. New web series can be added. Here subscribers can be added. Scalable. Right. Then asynchronous. You understand the meaning of asynchronous? Right. They are not happening at the same rate. Same rate. It is not that publishers are publishing it and immediately you are watching it. It is not like that. Speeds are different. Asynchronous. Right. Fine. Users. One of the important point is users broker. Users broker. Right. So example, your Netflix, right? In IoT, example, right? You subscribe for a weather forecast. Any website. Any random website, you subscribe it, then only the notifications, the messages will be sent to you. Weather forecast. Clear? Public subscriber model is clear?
Yes, sir.
Then shall I go to problem? Third one is push pull communication. Something push pull. The moment you hear the words push pull, what is that comes to your mind? As a computer science engineer, what is that comes to your mind? Say. Stack. Then GitHub. No, fundamental things. Not go for applications. What kind of data structures comes to your mind? Stack. That's it. Queue is the best one. Stack is first in last in first order, right?
Yes.
Queue is first in first order. That is the most suitable example for push pull. So what you assume here? What you guess here? There is a queue here in this communication model. Yes, of course there is a queue. Right. So here also same thing. Should not have erased the diagram. Right. Here I have publisher. Here I have consumers. Consumer 1, consumer 2. Here I have queues. Right. What is QU? Spelling is correct? Here we have queues. Here publisher push messages in the queue. Consumers pull messages out of the queue. Actually, I could have taken another what reasoning there. Why it is needed? Yes.
Required.
Yes, of course. You write those sentences from publishers, push messages on the group, as it is visible in the diagram. Consumers pull the messages from the queue. Yes.
First message.
Why this model? Why this communication model? Right. Wasn't this first communication model, the request response model, publish subscribe model was not good? Why did we design this? What was the reason?
Ordering of messages.
Okay, I will give you an example. If I say Q is equal to buffer, then now we should be able to give some explanation. We should be able to give explanation now.
All at once will not go to the consumer. Everything at once will not go to the consumer.
Hmm.
So there needs to be storage in the kind of buffer. Consumer can access from there.
Okay, one answer explanation.
No,
Yes, madam.
no, no.
No overflow. You go to Tirupati. You go to Tirupati. What is the procedure of getting darshan? You have to be waiting in the rooms. Do you remember?
Yes.
Why it is happening?
For our time, the waiting time.
Why waiting time?
So it is a traffic.
After process,
It is because the rate at which publisher is publishing and the rate at which consumers are consuming are different. The bhakta is, the devotees rate, the rate they are going to Tirupati is higher, but the rate at which they are getting the darshan is lower. Hence you have to wait in the queue. If some VVIP comes, you will take some extra path, special path, again you have to be waiting. Right. What does it mean? Does God know this? When VIP has to give darshan earlier. Right, irrespective of that. Right. Understood?
Yes, sir.
So, when we use this communication model, what is the key point? The key point is rate, exactly. Speed mismatch or rate mismatch. Rate is with respect to time. Right, the messages that is generating with respect to time of transmitter, that is publisher, and the message it is generating per time of consumer. Right, so there is mismatch, higher, lower. In that scenarios, the queues comes into picture. Now you can take a practical example. Now I am expecting the example from you people. Sometimes there is load imbalance also this happens. Another case, right, load imbalance, flexible processing. It's flexible. It is not necessary that you have to tune to the receiver's speed, or it is not necessary that the receiver or the consumer is going to tune into the publisher's speed. Flexible. It is flexible. Example, the most classical example is your email services. Here I have put network connectivity. 5G. Airtel is 5G. I will send you the mail. But you are using Geo, whose network is not good. Whatever email I have sent, will it vanishes? Will I lose it? No, it will be in the queue. The moment the Geo person goes into a good network area, immediately will receive the email. Is it clear? Right. Email or IoT device also some example you can give, no problem. Concept is simple. The rate at which the publisher is sending the message and the rate at which the receivers, consumers are accepting the messages, mismatches. Most important point of the push to communication mode. Is this clear?
Yes, sir.
So repeat it. First one is request response communication model. Second one is publish subscriber communication model. You remember all those things. In day-to-day life, when you come across the applications, you have to remember. Suppose you are developing a new application. You are developing a new application. In that scenario, you should be able to think. You are developing an IoT application. You should be able to think which communication model will be the best for my devices to exchange the data. What is the reason behind understanding all these things? Whenever I am developing an application, I have to choose one communication model. Is it clear? Yes. So end to end, what happens in the IoT? Device with a sensor will collect the data, it will put it in the cloud. An app, a mobile application or a web application, it will take the data from the cloud. It will access the data from the cloud. Means at the end it is collecting the data or it is accessing the data which the sensor has collected. Via the cloud. We will also see whether it is necessary, cloud is necessary or not necessary. There are also parameters. It all depends upon the applications. Is it clear?
Yes, sir.
And which one is the last communication model? Don't turn the paper, then what is the use? I am asking. Simply I won't ask. That's it. Turning the paper is of no use. Right. Whenever you call your parents, when somebody call your parent, you are on call, you are speaking to your parent, other person calls, will it disconnect automatically and you start speaking to them? No, it does not happen. Right, because initially when you pair up with your parents on call, it is exclusively paid. Communication model. If it is urgent, you stop sending message or email, you go for exclusive pair communication model. Right. If it is not urgent, if your parent is not in the network, see, what I am saying is how their today life is. Only thing you need to be able to connect. Now, your parent, your father is not in a coverage, not in network coverage. What you do? Speak up. You'll put a message. Then which communication model you are using? Pushful. Q you are using. Because you understand he is not in network, his rate at which he is receiving the message is slower, so we will put it, and whenever he comes into the network, we will see. Call back. Nowadays, whenever you call somebody, if they won't pick the call, by default the message will come. I will call you back. I am busy. Right. He may be sleeping also, we don't know. But busy. Right. But what happens? Nowadays, when we hear people calling, we are not accepting the call. It means what? We may be busy, we are doing some work, or we are not in the reach of the phone. Those people won't understand. Immediately they will call. Yes? Right. No common sense. He will call back. He may be busy. So second time also we didn't receive the call, we didn't accept the call. Third time they will call, back to back, back to back. Have you encountered such people? Yes. Right. I got fed up. What is like? The call, so immediately when I pick the call, especially our students, sir, where are you, sir? Just now I have landed at Singapore airport. See, there is something, manners, protocols. Good afternoon, sir. So I am a particular C3 student. Right, I am a CR of the student class. May I know, sir, when are you available? May I know, sir, when you will take the class? No, sir, where are you, sir? Right. Last one, let's please repair. So it is full duplex. Full duplex communication model. You understand full duplex? We have different type of communication modes. Simplex, half duplex, full duplex. This full duplex communication model. Right. It is continuous. It is continuous. Once you get connected to the call, right, it is continuous, no interruption. No interruption. Right. And it is in general, in principle, one to one. When the technology evolves, we may wait one to many, etc., etc., but it is one to one. Right, one to one, generally. Right. Key points. What are the key points? It should be low latency. Low latency. As a computer science engineer, you understand what is latency? Yes or no? Right. Request response. Whatever it is service, the response, what are the whole time? That should be as low as possible. Sometimes when the network is low, you observe the WhatsApp, right? There is a delay. Whenever you play a video game, there is a delay, which it has high latency. High latency. And this should be secure. Right. And again, it should be, it is not scalable. It is not scalable. Right. In general speaking, of course, right, if you go for a WhatsApp group call also, there is a limit. There is a limit. We should think in a relative way. Are you getting me? This is clear? Yes. So, diagrammatically, right, we have client, we have server. Request to set up, request to set up connection. Means you are ringing. You are ringing. Right. Most of the students are when I see 3-4 years back, whomever I call. The song I used to hear is Imke Kawali. What I Kawali? This is the call that I want. Why am I calling you? You lift the call and answer. What else I want? The trend change. Everybody will not say after 2-3 years. Trend change. Everybody. What is that song? Undi Podave. Everybody. I think you also part of it. So, whenever I call, whenever it is ringing, I am requesting to set up the accepted. Request accepted. Send message. They will send the message. Then request to close. To close connection. Close or end connection. Close or reduce end connection. Accepted. Clear? Example, phone call, remote in IoT example, remote robot control. In mining, suppose in mining, or some emergency situations. Clear? So these are the four communication models. Right. So whole point of discussion is when we are designing an IoT application, of course our IoT communication in the definition, what it is communication? They share the data of their environment and the user. In the definition, the last sentence, yes, which there will be a transmitter, this will be a receiver. So which communication model is suitable? You have to take. Clear? Shall I erase? Any doubts till now? Simple, these are simple things. I think in computer networks or in any other subject matter. Okay. Which is the best communication model? Yes? Simple. Based on communication. Based on the requirement. Based on the requirement. When there is a requirement of request response model, if I use exclusive pair, what happens? Wastage of resources, because this is not scalable. This is exclusive pair. I cannot serve hundreds of clients at a time. Are you getting me? In request response, communicate and forget. It is a stateless. It is a stateless. Communicate, who that person, either person doesn't care, no information is retained, no session information is retained, when logged in, when logged out, nothing is retained. Is this idea clear? Now let us do it. What is the time?
225. 225.
2:25. What is the size? How much time?
38 minutes.
38 minutes. Okay, so then in tomorrow class we will see APIs, application programming interface. Now close it down.